10th Physical Science, Electricity. Today we are going to learn about the factors affecting the resistance of material. Resistance means the obstruction to the motion of electrons in a conductor is called resistance. For example, here we can see the motion of the electrons from one end to another end of the conductor, and the lattice ions present inside the conductor collider with the electrons and obstruct the motion of the electrons passing in conductors. So it is called resistance. So some factors affecting the resistance of material. Then resistance means R. R is equal to V by I. V means potential difference and I means current. So like this also we can say V by IR. It means R is equal to V by I and I is equal to V by R and R is equal to V by I. So from this triangle we can say V is equal to IR and I is equal to V by R and R is equal to V by I. And SI units are 1 ohm and the symbol is like this, and 1 ohm is equal to 1 volt by 1 ampere. So these all about the resistance. And the effectors are temperature and the nature of materials and the length of the conductor and cross section. So these 4 factors are affecting the resistance of material. First one, temperature and resistance. So here is the activity. So in this activity electric circuit is there. So in this circuit bulb connected to battery with a conductor. Conductor means wire. So when we on this key, so the current is from battery to bulb flowing. So the current is flowing through this conductor. Before connecting circuit, the resistance value is taken. After connection the circuit, the bulb glows. Wait 5 minutes and take in the resistance values. You will notice that the bulb gets heated. The increase in temperature of the filament in the bulb is responsible for increase in resistance of the bulb. So temperature affecting the resistance of material. So first, before connecting the wire, we can taking the resistance values, and after connecting the bulb to a battery through the conductor, when we on this key, then also the current pass and reach to the bulb and the bulb also glow brightly. So wait 5 minutes. So after 5 minutes or 10 minutes we observe that the bulb getting the heat. It means temperature. So the temperature of the bulb is increased. Then also we observe the values of the resistance. So here we observe the resistance values also increased. So we concluded that from this activity the temperature is affecting the resistance of material. And second one, nature of material and resistance. So here also we can see the circuit, and here the battery is there, and the wire is there, and ammeter also attached to this conductor, and between PQ and both ends of the wire. So here different metal rods are connected between P and Q. So same length and the same cross sectional area metals are taken. So what type of metals are taken here? First one copper, and second one aluminium, and the third one iron. So these three types of metals are nature is different. Okay, so the nature of the materials means copper, aluminium, and iron. So one by one we keep this metal and connect it between the P and Q. First we read about this activity. Connect one of the metal rods between the ends of the P and Q. So first one means copper. First keep the copper piece between the P and Q. Switch on the circuit. Measure the electric circuit by ammeter and note down the in notebook. Repeat this with other metal rods and measure electric current. In each case, the values are different. So when we keep one by one these metals between P and Q, we observe that the values of the resistance are different. So from this we conclude that the resistance of a conductor depends on the material of the conductor. So it is also factor, that is a nature of material, and this is also affecting on the resistance. Next, third one, length of the conductor and resistance. So here three sizes of the metals are taken and electric circuit is formed here, and small length iron spoke is taken, and second medium size iron spoke is taken, and third large iron spoke is also taken here. Different lengths of iron spokes connected between P and Q, free ends of conducting wires. So PQ is a ends of the conductors. So three sized iron spokes are kept between P and Q one by one, and observe the resistance power. Different length of iron spokes collected with same cross-sectional areas. First, small length iron spoke connect between P and Q, forming circuit. Measure the value of current by ammeter. Repeat this for medium and long length iron spoke and measure the value of current, and note down the in notebooks. The current increases with increase in the length of the spoke, and the resistance is increases with increase in the length for the constant potential difference. It means R proportional to length. It means one by one the small size, medium size and large sized iron spokes are keep between the P and Q and observe the current passed through these conductors, and also the resistance values also observed. So from this activity we observe that the current increased and also the resistance also increased. So the resistance proposed to length. So when the length is increased, automatically the resistance power is also increased. Next one, cross section area and resistance. Cross section means here two types of conductors can be seen here. So first conductor, it has a big cross section, and second one has a small cross section area. So in this we observe here between the conductor we can see the cross section A present between the conductor, and the potential difference also can see between the two ends of this conductor, and here also small conductor also has a small cross section area, and the current passes through this conductor, and the potential difference also can be seen between these two ends of the conductors. Connect the big cross section area iron rod between P and Q and note the values of current. Repeat this with a small cross section area iron rod between P and Q and note the values of connection. We observe that first we take in the big cross section conductor and observe the values of the current and also resistance power also. Next, when we keep the small cross section area conductor, here also we observe the values of the current and the resistance power also. We notice the current flowing through high big cross section area iron rod increases with the increase in its cross section area. Hence the resistance of iron rod decreases with the increase in the cross section area of the iron rod. So the resistance of a conductor is inversely proportional to its cross section area. So it means when the cross section area increases, automatically the resistance power is decreased. So it says as it is inversely proportional to its cross section area. R proportional to 1 by A. R means resistance, A means cross section, R is equal to rho 1 by A. Here rho means specific resistivity. SI unit of resistivity ohm, and low resistivity metals behave as a good conductors. Example, coppers. Filament in bulb made by a tungsten have a high resistivity. And semiconductor has a high resistivity. So three types of metals are there. First, good conductors. So good conductors has a low resistivity, so it behaves like a good conductors. For example, copper. And the filament in bulb made a tungsten, and it's have a resistivity high. And semiconductors has also have a high resistivity power. So here we learn about the four factors affecting the resistance of material, and they are temperature and the nature of the material and length of the conductor and cross section area. So these four factors are affecting the resistance of material.